Okay, hi everybody. We are doing a quick review on section 7.1, part 1, which is combining like terms. Now we've talked about this already, but we're going to go through it again just so everybody gets it. What we're doing today is we are learning to combine like terms in an expression. So let's go on with the do now real quick first. You must know how to do this in order to combine like terms. Okay? So I invite you to pause the video, try to work on these on your own, because if you can't get these, you'll really be stuck in math forever. Okay? So, pause the video, do these, unpause it, and we'll go over it. All right, now we're going over it. 5 take away negative 3. Well, I put up a number line for reference here, if that helps. 5, and we are getting less negative. Less negative is that way. So I'm going to go that way 3 times. 1, 2, 3, and I get 8 as an answer. Another way you could have done it is that when you subtract a negative, it's the same thing as adding, so 5 plus 3 equals 8. Number 2, negative 7 plus negative 2. Well, I start at negative 7, and I get more negative. I'm going more in the negative direction, which is that way, by 2. I wind up at negative 9. Okay? Moving on. Number 3. I start at negative 4. I get less negative by 3. So if I start at negative 4 and I get less negative, which by the way is that way, 3 times, 1, 2, 3, well I wind up at negative 1. The other way again I could have done this. I see that this is just adding. I start at negative 4 and I know adding goes to the right, so my answer will be negative 1. Finally, 6 plus negative 2. I start over here at 6. I am going to get more negative. More negative is going more in the negative direction, that way, by 2. So I wind up at 4. These are absolutely essential to be able to do what we're about to do next. But first, I think we've got some vocabulary to talk about. This is an expression here. It is a set of terms. Here's a term. Here's a term. A set of terms that go together, but there's no equal sign. If this was an equal sign here, then I would have an equation. But I don't have an equal sign, so this is just called an expression. It's just something, it's like a sentence fragment. This thing right here is just part of what we can talk about in math. So 6x plus 7. Now, the 6, I've color-coded these. 6 is my coefficient. What that means, well, let's talk about green first. I'm sorry. Green here is my variable, okay? This is my variable. I have it written right down here. And what the variable says is, what do I actually have? Okay? This is talking about what I have. The coefficient, which is the number in front of the variable, it's a fancy word, but you do need to know it here. This coefficient is the number in front of the variable. What that tells me is I know what my variable is now, but now I want to know how many of them do I have. So what this expression is saying is that I have x's, I have a pile of x's, and I have 6 of them. So whatever x is, I have 6 of that many. So if x is 1, I have 6 groups of 1, which is 6. If x is 2, I have 6 2's, which would be 12. And then finally, this number off by itself that doesn't really have, it doesn't have a variable with it, that's just called a constant. It's another word for just some ordinary number. Okay? Now let's talk about our vocabulary. Terms are parts of an expression that are separated by plus or minus signs. Okay? So this could have been 6x. Instead of that plus, it could have been a minus, and we still have an expression with 2 terms that are separated by plus or minus signs. Like terms, so an example of this, let's go back to terms for a second. An example would have been 4x. That's a term. 5j. Negative 3. It doesn't have to have a variable. It just has to be something, like a number or a number with a variable. 4x, 5j, negative 3. even something with an exponent, b squared, or 7x to the 5th. These are all terms that we might see in an expression. Like terms are terms that have the same variable raised to the same exponent. For example, 5x and 7x. These are the same exponent, they both have x, and they both are raised to the first power. Remember, when no exponent is written, that means it's raised to the first power. Let's do another example. Another example of like terms might be 2b squared and negative b squared. Notice I have the same variable here, b, in both cases, raised to the same exponent, the 2. Okay? So I have the same variable, same exponent. These are like terms. That means that I can add and subtract them without breaking any mathematical rules. But what if I had like a 2y and 4y to the third power? These are not like terms because even though they have the same variable, they have a different exponent, and that makes them not like terms. I cannot combine them. Now, let's talk about equivalent expressions. These are expressions that have the same value no matter what the value of my variables is. Okay? So, an example of equivalent expressions, 2x squared is the same as let's see. Let's see. 2x squared would be the same as 4 times x divided by 2. These are equivalent expressions because I will get the same answer no matter what number I plug in for x. I will always get the same answer for each of these expressions. So if I plugged in a 1 here, I would have 2 times 1 is 2. If I plugged in a 1 for each x over here, I'd have 4 times 1 divided by 2. That would also give me a 2. Okay, so those are equivalent expressions. And to simplify, we use that word a lot, but let's define it. Simplify is the process of performing all possible operations, including combining like terms. And maybe I should say especially combining like terms, because that is a big part of simplifying. Okay, now let's do a couple of examples. Like terms, I've got a whole heck of a lot of terms here. And what I'm going to do is I'm just going to start grouping them as I see them into groups that are the same. So the first one I see is -9, so I'm going to put it up here. That's just a number. It has no variable and no exponent. So the next time I see a number that has no variable and no exponent, I'll put it someplace. I'll put it in the same circle. 5b squared is the next one I see. So I'm going to put that over here. All of my b squared terms will also go down here. What do I see next? I see a 7x squared. Well, let me see. Are these like terms? No. In the red circle, there are no x's. In the green circle, there are no x's. So I'm going to have to make a new group. I'll call it the x squared group. What do I see next? I see a -4y. Again, I haven't seen a y yet, so I need to make a new group. Next one I see is 10y. Well, I've seen y's already. I see this -4y. That has the same variable raised to the same exponent, so those have to be like terms, and I'll group them together. 10. This is a number without an exponent, or without a variable, so it's going to go with the other numbers without a variable. I see -4b squared. Once again, it's going to go with all my other b squared terms. Okay? Notice the numbers don't really matter at all when we're talking about like terms. It's what's after them, the variable and the exponent. Okay? I see a 6xy. This has 2 this has two variables to it. It's got an x, which, no, I haven't seen an x yet. I've seen an x squared. I've seen a y, though. But I cannot put this here because the x times y is the variable that I care about. It has to have an x and a y to be a like term. So this is going to go by itself again. Finally, I have an x just by itself. I haven't seen that yet, so that's going to go down here. And then it's just a matter of starting to match these, because I have 6 groups. And all I have to do is look for the variables and the exponents and see, well, what's like everything else. 2y is like the things that only have y's. That's over here. Negative 2 is like the things that have only numbers, so that's going to go over here. 2b squared is like all the things that have b squareds, so that's going to go right over here. That is to say, right over here. Okay? X squared is like all the things that have only, or negative 8x squared is like all the things that have x squareds with them. Okay? Negative 3xy is like all the things that have x and y together. 8x is like the things that have x's. 6 is like the things that have only numbers. 2 is like the things that have only numbers. 2xy is like the things with xy's. Okay? Negative 3 is like the things with just numbers. 5y is like the things with y's. I'm not real sure what just happened to that, but it was supposed to go up in the top right. 3y, same thing. It goes up here. Negative 4x. Where are my x's? They're down here. So that's where this is going to go. And negative 2x. It's down here, so that's where that's going to go. This is like terms. All you have to do is look for the variable, look for the exponent, and group them together. Anything in this group right here can be added and subtracted. Anything in this group right here can be added and subtracted. Anything in this group here can be added and subtracted. Anything that's in 2 different groups, you can never add or subtract these. Let's do a couple of examples about what I mean by that. So, when I combine like terms to simplify, what I'm going to do is I'm going to think about, well, what terms are like each other? Well, I see that this 2x is the first thing I see, so I'll label that with a green circle. Anytime I see another term that is similar to it, I will also put a green circle around it, which happens to be the next one I see, because plus 3x, they both of these expressions, both these terms, have x's in them. So I know that these are like terms. They both have x's raised to the first power. Okay? So 2x plus 3x. What I can do here is I can actually combine these a little bit. I can say, well, they both have an x, and I have a 2 plus 3. What I'm doing here is I'm just separating the coefficients a little bit from the variable. I'll do 2 plus 3, and then times my x. This is part of the distributive property. Okay? And then I can just add 2 plus 3, and I get 5x. This might make sense, because if I had 2 x's in one hand and 3 x's in another hand, and I added them together, pushed the hands together, well, I've got 2 in one hand, 3 in another. They just add together to give me 5 x's. Okay? So remember, the x is what I had, and the 5 is how many of them I had. I'm going to go to the next one and try to combine some stuff. Once again, I use my green circle for the first term I come across, and there's nothing magical about a green circle. It's just showing you that these are like each other. And then the next thing I see is a 3x. Well, that's different from just a number, so I'm going to call that something else. I'll label it, I guess, with this purple square. And then I see a 4. Well, that's just a number, and that's very, very similar to the 2 I had already, which was also just a number. So I will label that with a green circle again. And then I see a plus 4x. Well, that has just an x, just like my 3x did. So these are going to be my like terms. And so what I'm going to do is I'm going to be able to add my like terms together. My green like terms were 2 plus 4. And my purple like terms, let's see if I can pull up purple here. Okay, my purple like terms were plus 3 plus 4 times x. Okay, because I've got a 3x plus a 4x, and what I'm going to do is I'm just going to add those together. I get that those give me 7x. And plus what my green gives me, 2 plus 4, is going to give me 6. So the most I can actually combine these is to say that I have 6 plus 7x, or the way we normally like to write it is the other way around. It means the same thing. 7x plus 6. And that is as simple as I can get. Because these are not like terms, I cannot add them anymore. Okay? And then finally, I've got this over here. 5m squared. Well, that's the first thing I come across, but I can't reach the green circle anymore, so I'm going to call it something else. I'll call it a diamond, a blue diamond. Okay? So I've got 5m squared. And while I'm at it, I'm going to label any other m squared terms I have, which is this right here, this minus 3m squared. Okay? Now I'm going to go for another symbol. I've got a red pentagon. That's going to be my 2m. And I have no other m terms, so I'm going to find another shape, my purple square. This 8 and this 6 look like good candidates. And so I've got 3 different shapes here, so I better, when I'm done, have 3 different terms. First thing I'm going to do is I'm going to combine my m squareds. I know I have m squared, and there was a 5. And look at this, be careful, minus 3. It was minus 3m, okay? And so that takes care of these. I'm just going to cross them out to know that I've already dealt with them. Okay? And then I'm going to do my red. I get minus 2m. And you know what? That's all there is, so I'm done with that. And then I'm going to do my purple. I get plus 8 plus 6. Those go together. And now I'm going to combine my like terms. Well, 5 minus 3 gives me 2, so I have 2m squareds. Minus 2m, and then plus 8 plus 6 is going to give me 14. I cannot do any better than this right here, because m squared and m are not like terms. They are different from each other, so I have to treat them separately. And this is the most simple, or the simplest I can get my expression. So this is the most simplified form I can do. Okay? And now I'm going to move on. Let me just check what else is left here. Okay, I'm going to go back real quick. Okay, I'm going to do these very, very rapidly. I notice I've got an x squared and an x squared. So I'm going to do, I know that they are like terms. So I'm going to put x squared out here, and I'm going to take my coefficients, 3 minus 5, and I'm going to combine them. However, 3 minus 5, if you do it on a number line, gives you negative 2. So my answer here, my simplest combining of like terms, gives me negative 2x squared. Okay? I'm going to do the same thing down here. I see that I have an x squared and an x squared. Those terms are like terms. And then I have a positive 7 and a negative 3. I know that those are like terms. Okay? And so what I'm going to do, I'm going to combine the things that I know I can combine. I know I can combine this 3 minus 6 times x squared and this 7 minus 3, which were just my numbers. Well, 3 minus 6 gives me negative 3. So I get negative 3x squared. 7 minus 3 gives me 4, so negative 3x squared plus 4. And that is the simplest I can get because negative 3x squared and 4 are not like terms, so I can't combine those anymore. I'm going to go on to the next page. We can also combine like terms in two variable expressions. Before I was talking about just what x is and maybe x's with numbers, but there's no limit on the number of different variables I can have. So here I see a k, so I'll circle that with a green circle. And I see another k over here, 4k, so that'll get a green circle. But then I see another variable, n squared, and another one, again, n squared. So those are like terms to each other. So this time I actually have two variables. I can combine each of them separately. I can combine the k and the 4k. And what this is, I'm going to put it, again, I put my parentheses to talk about my coefficients. But I know I have plus 4. What was my first number? There's no number written here. So I need to remember, when I have no number, how many of them do I actually have? Well, I have one of them. So this is a 1 plus 4 times k. And then I'm going to do my purple plus, well, I've got 3 of the first ones, and then take away 2, and all of that times n squared. Now I will combine these. 1 plus 4 gives me 5 k's. 3 minus 2 gives me 1 n squared, and there was a plus in between them. So I have 5k plus 1 n squared. However, we normally put the term that has the highest exponent first, and we normally don't talk about the 1 like we didn't talk about the 1 over here when I just said k. So I'm going to say I have n squared plus 5k. Now there's nothing wrong with this one right here, but the second one, the one that I boxed, is what we normally write. The higher power first, and then the lower powers as they go on. And let's look at number 2. Again, we have various terms. I see an f, so I will put that with a green circle. I see a g squared. I haven't seen one of those yet, so I need a different symbol to talk about that, because that's not a like term with anything. And then I see a 15. That doesn't have any variable at all, so I need a third symbol yet. And when I have 3 symbols here, and none of them are the same as each other, there's nothing I can actually do. There's none of these that I can combine. The only thing I can do is say, well, I normally like these with an exponent. I like those terms in the front, so I'm going to say negative 9g squared. I have to put this negative here because it was a minus sign over here. Negative 9g squared plus 3f plus 15. And I started with 3 terms, and I'm ending with 3 terms because none of them are like terms. I can't combine them. This is the most simplified I can make my expression. It is your turn to simplify these expressions by combining like terms. Remember, only combine the like terms you possibly, that are terms you can combine. So if you start with 3 unlike terms, you will end with 3 unlike terms. If you start with all of them being like terms, you'll wind up with only 1 expression at the end. So those are for you to try. And finally, we're going to apply this by finding perimeter. Okay? Remember, perimeter is just adding up all the sides. So for this one right here, I get that the perimeter is 5 plus 4 plus 5 plus, uh-oh, I don't know this last side, so we called it x. But we can combine our like terms because this is kind of ugly, having 4 different things. 5 plus 4 plus 5, these are all like terms to one another, so I can add those together, and I get 14. So I get 14 plus x, but we know that I normally like the variable written first, so I know that my perimeter is x plus 14. I'm just adding all of these up until I can't add anymore. Okay? And that's all there is to it. I'm just finding the perimeter. Okay? And number 2 is very similar. I find my perimeter by adding up the things on the outside. X plus 10 and I notice, hey, those are like terms. And I think to myself, well, how many of them are there? Well, there's one over here, and there's one over here. So I have 1 plus 1 times x plus 10. 1 plus 1 is 2, so I get 2x plus 10. That's the simplest I can make it because these are not like terms. 2x and 10 are unlike terms. So I say 2x plus 10. That's the best I can do on my perimeter. This is your turn. You will do the same thing that I just did. Combine these as much as possible until you don't have any more like terms. And then write the perimeter in the simplest form you can. And then we are done with this lesson.